Hey folks, sorry for all the internet trouble. I don't know why this stream is not going so well, so I'm just going to do this recording here. Oh, people are still in chat. Still can't spell recording. All right, so we're going to do the BigInt project here. Now that we have a little starter code going over here for project 4, and see if we can't finish this up here. Clean up some of this here, and we'll come and look at what BigInt might look like. Okay, and I don't think we really need an empty BigInt. We had this here earlier so that we could, have some of the code kind of stubbed out. So we'll come back there and we'll fix that. What we do need is our array list of type integer. This is the digits. And then we need a Boolean value to whether or not we are positive or negative. So I'm going to put this as positive, and that's going to be assuming true to start, because I think that'll make it like the easiest if we say yes, true for positive. Okay, so we create a BigInt. You have to give me a string value here. So what I'm going to do is I'm going to check that value. I'm going to check for value if it starts with value. No, stop. My goodness. Value dot starts with. If it starts with a negative sign, right, then I know that positive is going to be false. We are going to be negative. And then what I want to do is I want to loop through every character after that. Okay, so actually I'll say, let's do this. We'll say index 0. And then if it is, I'm going to put index to 1. Because I'm going to skip the first character in that string. I want to go to the next character. And then I'm going to say for... And now I already have index. I don't actually need to initialize anything, so I can leave it alone. It's a little funny to do that, so maybe we'll just do a while loop. We'll say while index is less than value dot length. I want to grab each character out of that string. So I'm going to go value dot value dot char at. There we go. Char at. Yeah, what was the at the index. And what we need to do is we need to turn that into an integer. So we're going to do integer.parseInt of the character there. So it's going to grab the character, turn it into an integer, and then I can add that to my digits list. So I also need to make sure digits, I need to initialize this as a new array list of type integer. That way I can start adding to it. So I can take my digits, dot add whatever that value is that I got out of my character. Not a string. That's fine. It's an individual character, and it won't parse an individual character. That's fine. We can go to string. No. Characters can't be turned into string. That's right. Okay, so character. Or I think we can say string given a character. Try that. New string given a character? No. Character dot toString given a character. All right, that shouldn't be so bad. Given a character, add an index, turn it into a string, so we can parse it as an integer, add it to our digits list. My goodness, that's long. Then, because this is a while loop, we need to make sure index goes up, index plus plus. So that should make our BigInt out of strings, as long as those strings you want to give me, right? I'm going to take it. If we want, we could ignore commas. Depending if we expect to have commas given to us in strings, we could do that. That's up to you. It's depending on how you thought you would be creating these BigInts. If you don't want commas, don't have commas. If you're expecting commas, when we do this parsing character by character, we could just ignore all the commas. That's just an option there. Okay. All right, and then we said we need to figure out whether or not we are bigger than another BigInt. Okay, so we need to check. We're going to see who has the longer length of digits, because that is the bigger BigInt at that point, right? So we're going to say if the digits dot size is greater than other dot digits dot size. If you give me another BigInt, I'm going to see the size of their digits, and if I have more digits, then I'm going to return true. Else if I have less digits than them, and really the else is kind of redundant there, because if we did a return, we're never going to get there anyway. So I'll just say if it's less than, we're going to return false. If it's not greater than and it's not less than, right? Oh, well, we need to go start comparing. We must be the same size. So we're going to say for int index is 0, index is less than digits dot size, index plus plus, and we're going to compare each of our digits, right? Check my first digit, their next digit, their next digit, their next digit, on and on and on and on, and see if we can find if we are bigger or smaller. So if digits at index is greater than digits, other digits at the index, at index. That's too many parentheses there. Okay, if it's greater, why is that yelling at me? Digits dot get. I'm sorry, get. Digits dot get this index is greater than digits get that index. I'm going to return true. If I didn't return true, I'm going to check, hey, if they're less than, we're going to return false, right? If we go through this whole for loop and we haven't returned true, we haven't returned false, then we must have the exact same digits. I'm just going to return false because we're not bigger. Right? We must be the same size, and we don't really have a good way to handle that right now. We just want to check, are we bigger than the other? Because it's possible we'll get a 0 result out, and that's okay for now. Okay? So how about a nicely formatted string? How do we do that one next? So if we use string builder, right, that's the right way to do things. Okay? We're going to say if positive, and really we want the not. So if we're not positive, right, that means we're negative. We're going to take our string builder, and we're going to append a negative sign. Right? Then we're going to start looping through every digit. Right? So for index is 0, index is less than my digits dot size, index plus plus. We're going to take our string builder, and we're going to append my digits get the index. Now this doesn't do the nice commas though, right? We need to figure out how we can be comma separated. Right? So what we need to do is if we have more than 3, we need a comma every time that there's less than 3 left. Or if every time that there's a multiple of 3 left. Does that make sense? So like if we're dividing the remaining number of digits by 3, because we want to go every even multiple of 3, we need to put a comma in there. So if I have 3 digits left, I need a comma. If I have 6 digits left, I need a comma. If I have 9 digits left, I need a comma. So if it's an even multiple, so if it mods by 3 evenly, we know we're going to need a comma. So at index 0, how many digits do I have left? Well, I have the length here, so this one is 8 digits long. So at index 0, I have the length, the size, right, of 8 minus the index left. I have 8 digits left to print. So we can just check that. So we can say if the digits.size minus index do that in order of operations, right? Force that to happen. If that modulus 3 is 0, means I have an even remainder of 3 left. Right? And I'm never going to be where index is size, so that shouldn't end up at 0. So once index hits 8, right, I'm going to stop because I don't have an index 8. I have index 0, 1, 2, 3, 4, 5, 6, 7 out of those. So let's kind of just walk through and see if that logic's going to work. So when index is 0, I get 8 minus 0. Sure, no comma. When index is 1, I get 8 minus 1 is 7, not evenly divisible by 3. When index is 6, or I'm sorry, when index is 2, I get 8 minus 2 is 6. Before I print the 3, I'm going to put a comma in there. I think that's going to work out. So we're going to append a comma. And again, there's tons of different ways you could have done this. Not a big deal, right? Any way that you got this to work with your comma separators is fantastic. This is just one approach, okay? So we'll try that. And then when we're done, we're going to return our string builder to string. Okay? So we could just try, oh yeah, these BigInts are failing here, that's why. That is unfortunate. I think we need a way to make these that don't take arguments. Okay, so that's why we had that other one. So we can put that back in, but it doesn't even need to be public. It could be a private constructor. BigInt, and it's set digits equals new array list, and positive equals true. I don't know. Just give them some values so we can make it here, but it's private, so no one can use this except for us. This is just to use in the add subtract methods. Right? I don't want anyone else to make a BigInt that's empty because they can't interact with it. They need to give the BigInt a value here. Right, but we can try a couple two-string tests right now if we wanted. Right, let's go over to our tests. So let's add some tests. We'll do add test public void test string. Okay, so we're going to arrange. We'll act, and then we'll assert. So what we're going to do is we're going to compare string outputs. So this is my expected output. Should be, right, maybe like negative 1, 2, 3. How about we'll do that? 3, 4, 5, 6, 7, 8. So that should be the output, right? So you know what? I feel like I want to parse commas now in our BigInt. I want to ignore commas. This way I can hand that same string to here, so we can check. We can say if if value dot. This hates me. Value dot char at index if it dot equals, oh, that's right, it's a character, so we can just compare characters directly. If it's a comma, if it's not equal to a comma, let's do this. How about that? Let's go add. Right, so if it's not a comma, let's go parse it. If it is a comma, we just ignore it. We just go to the next index. Okay? This way I should be able to take this expected output and hand it right to a BigInt. So we'll say a BigInt, BigInt equals a new BigInt. Given the expected output, it should parse all of that, and then we'll have a string for actual output is my BigInt toString, and we'll compare if they're equal. We'll say sort of equal, given my expected output and my actual output. The expected string might be better. That's fine. Let's give that a shot. Let's see. It's going to test our constructor and our output. Ooh, assertion. Oh, okay. Add to positive failed. So test to string worked. Seemed to be okay. This is with a negative. Let's do it with a positive. So let's try another one here with positive, with commas. Oh, let's do without commas. Without commas. So if we just give it, say, like 6, 7, 8, right? We should just get 6, 7, 8 back out. Okay. Let's see. Oop, toString Uh-oh. We expected... Oh, where's the message? Read the message. It was... Looks like a negative value there? Uh-oh. So BigInt... Oh, yep. Okay, so my constructor here, I was setting positive to false here, but it defaults to false. Right? And remember, when you have a Boolean, it's going to default to false. That's unfortunate. So we'll just say positive is true to start. And then if we find the negative, we'll set it to false. See, this is why we have these tests. Right? This is good. So let's run that test again. There we go. So my toString, oh no. Is it still? Oh, I got a comma. Uh-oh. It put a comma in the output. That's not what we wanted. Because index 0, the size was 3. So we only want to do this if our size is greater than 3, right? So if digits.size is greater than 3 and the length, the size minus the index mod 3 is 0. Okay? Because we only care about commas if we're bigger than 3 characters. If we only had 3 characters, then we're not going to bother with any of those commas. All right, let's try the test again. So this is good. This is good. We're figuring it out. All right. We got it. It passed. So I'm feeling pretty good about our toString so far. Feeling pretty good. So we need to do add and subtract. Right? So we don't want to change us. We don't want to change the other. So we can make this BigInt and then we can start adding values to it here. Okay? So remember, if we're adding a positive and a positive, great, easy. If we're adding a positive and we're adding a negative, it's really like subtraction. So we're not going to add anything here. Then we'll have to flip around and subtract. If we have a negative, adding a negative, great, we're good to add them up and the new result's negative. We have a couple cases there then, right? Otherwise we need to do subtraction and see which one is bigger, right? So let's see, there are 2 cases then for adding is going to be if they're both positive or they're both negative. Then we'll actually add them together. So we'll check. We'll say if positive and other dot positive, right? If both of those are true, or not positive, negative, and other dot positive and not. Right? So if we're both true or both false, then we're good to go. Positive. Yes. Okay? So if we're positive and they're positive, or if we're negative and they're negative. Because if we're negative, not false would be true, not false would be true. Then we're good to go. We can just add them together. Okay? We have to do the stuff to add all these digits together. We're going to return our new result. Okay? So what do we need to do? Well, we're going to go through and we need to start at the ones place of each BigInt and start adding them together. Right? So we're going to say for int index is equal to, and really we actually need to do this with both values here. So I'm going to have a myIndex as an int. MyIndex is digits.size -1, and an int for other index is other.digits.size -1. Okay, because that'll get me the last value, the last index in each of these. Right? And I'm going to say while myIndex is greater than or equal to 0, and the other index is greater than or equal to 0. Right? Well, they're both greater than 0. I've got values there. I can keep on looping. Right? We can keep on going there. Okay? Then what we're going to do is we need to be tracking whether or not we have a carry. So I'm going to have a Boolean here This is just my approach. There's lots of different ways to do this. We're going to say carry is false to start. Okay, because we don't know. We're going to assume there's not a carry until we found out otherwise. So I'm going to take my index, or my digits at my index, and the others digits at the other index. I'm going to add them together. Right, so I'm going to have an int new digit is my digits get my index plus the other dot digits dot get other index. All right, we'll add them together. And then if the new digit is greater than or equal to 10, we're going to have a carry. I'm going to say carry is true. And then I'm going to take that new digit and I'm going to mod it by 10. Mod equals by 10. Or really, I could just subtract 10, I guess. Either way is fine. We'll just take away 10, because that's the digit. And actually, before we do that as well, if there was a previous carry, we need to add it, right? If there was a carry from previously, so I'm going to say if carry, we're going to take new digit plus plus. We'll add 1 to it, and then we'll say carry is false. We've used the carry. So if there was something to carry, we'll add 1 to our digit, and we'll set carry to false. And then, hey, if we're greater than or equal to 10, we have a new carry to add, and we're going to take away 10. Then we can add that new digit. So we're going to take the new result here, right? We're going to go to its digits, and I want to add at an index here. I want to add at index 0 the new digit, because what that's going to do is going to put it at the front. So my first character, first digit goes at the front, the next digit goes at the front, the next digit goes at the front, and at the front, and at the front, and at the front. We're going to build it from the one digit out. If we keep appending, then the first digit we put in would be the largest one. We want it to be the smallest one. I'm going to set it there. Okay? And then we need to move my index and other index. So my index minus minus and other index minus minus. Right? Once this loop here is done, if either one of these gets to be less than 0, I ran out of digits. Well, now I need to see, well, I might still have more digits. Right? So I need to see. So if my index is greater than or equal to 0, I need to keep going. Or I might have an if other index is greater than or equal to 0. I don't know which one. Or it might be neither. But if we have some, then we need to keep going. Okay, we're going to do that same thing. So we're going to have now a new digit, an int. New digit is going to be my digits dot get my index. And then if there's a carry, right, because there might have been a previous carry, new digit plus plus. And I can just repeat this logic here, which is a little bit sad, but that's okay. Don't worry. Here, I'll just grab that. I'm going to feel a little bit bad about it, but it's okay. So if there's a carry, add to the digit, set carry to false. If the new digit is greater than 10, we now have a carry. New digit's there. And then that new digit can get added to the new result. And then my index goes down by 1. I'm sorry, this is another while loop, not an if. While, okay, same for the other index then. Except now it's the other dot digits. Get at the other index. If there's a carry, great, add to the digit. So we've used the carry, set it to false. If we hit 10 or more, there's a new carry, subtract 10. So this is like if we had a bunch of 9999999s, right? We should be able to add that new result and take away that index. There we go. Other index needs to go down by 1. That would have been a bad bug. See, copy paste is dangerous. And then whether or not we're true or false, or I'm sorry, positive or negative, right? So my new result dot positive should equal. Remember, I know we're only here if we're both positive or both negative. So I'm just going to set it to my positive. Right? Because it's either positive or it's negative. So if we were both positive, it's a positive number. If we're both negative, it's a negative number. We just made a bigger negative. So I'm either positive or negative. We'll set it to that. So that should work for both positive and both negative. That's the easy, those are the add ones here, right? You okay so far? So now the harder ones, right? The subtraction. I guess maybe not even harder. So we need to make sure we're going to subtract the smaller number from the bigger number, right, when we do this. Okay, we can try it. Let's see. So if we didn't do this thing, we know one of us is negative and the other one is positive, right? Because we're not both positive, we're not both negative. So it's either I'm negative or the other's negative. Doesn't matter. We just need to find out which one is bigger, right? Okay, we can do that. So we're going to find out, we're going to say if self dot is bigger, oh, I'm sorry, is bigger than the other. Right, that was the little method we wrote to find out whether or not we're bigger than the other one. If we are bigger, then we're going to subtract the other from me. Right, now the problem is I don't want to call this subtract method. Right, I want a little private helper method here, BigInt subtract smaller from bigger, BigInt other. Because I'm already going to figure out which one is which here. This one could be either way, right? I don't want to use this subtract because it might not even be a subtraction function. Right? If I do it wrong and I have like a negative in the wrong spot and I go and subtract a negative, bad stuff, right? Because really, if I'm adding a negative number, it's like subtraction, but then I need to change the BigInt and do all this funny stuff. So this is just going to subtract smaller from bigger. Okay, that's fine, and we can figure out the sign after, right? I will say ignore sign. Okay, so if I'm bigger, I'm going to have a BigInt result is subtract smaller from bigger, other. Else, if I'm not bigger, right, it's going to be the other way around. So it's going to be other dot subtract smaller from bigger given me. So self is me, right? I'm self. Oh, I'm sorry, this. Sorry, wrong language. This. So this instance, that's us. Okay. Then we need to figure out the sign, right? Because this is we don't want it to set a sign. We just want it to do some subtraction. So we need to figure out, are we going to be negative or positive? So we're negative here, right? Because we know that we're bigger. So we're only negative if we're negative. So we'll say the result dot positive equals our positive. So if we were negative, positive, then we were adding a positive number. It's still a negative result because we're bigger, right? If it wasn't, then they were bigger, and we're going to be result dot positive will be the other dot positive, right? If they were a positive number and we were a negative number, it's still positive. If they were a negative number and we were positive, but they were bigger, then we're negative. Okay? And then we can return result. And return the result. Okay? This way, all the subtraction has to do is the subtraction logic. So we're going to make a new BigInt. BigInt result. The new BigInt. Okay, that's our little private helper here. Now we just need to go do our loops. So our loops are going to be very similar here, right? Mine and other. And let's see. I don't want to, maybe we'll copy some of it. I don't know. Well, that's fine. So we'll have an int for my index is my digits dot size -1. I'll have an int for the other index is the other dot digits dot size -1, and while, there we go, my index is greater than or equal to 0, and the other index is greater than or equal to 0, I'm going to keep on going. Okay? So we need to do the first subtraction. So we know we're the bigger one. So it's going to be the bigger minus the smaller. But we need to figure out whether or not we need to do the borrows or not. So we'll have an int, or we'll have a Boolean for borrowed is false. Okay. So, and borrowed is really just going to, add, it's going to add to the result. So that's going to be a little funny. That's okay, we'll figure it out. So we'll take the int for my digit is my digits dot get my index there, and then if borrowed, right, then we have to take away 1, my digit minus minus, because we borrowed 1 from it, and then we'll set borrowed to false. Borrowed equals false. Okay. Then we can look about the subtraction. So then the int their digit, we'll have an int, I don't know, I guess we'll do it down here. Int other digit is the other dot digits dot get the other index. Get their index out. Oops, sorry, it's a semicolon. Not a curly brace. Okay, so we got the other digit. Now we're going to see if we can't do the subtraction, we need to go borrow. But we know we're subtracting the smaller from the bigger. Right? We know the other is smaller. So we're always going to have something to borrow from, because we did that check before. So we can check if the other digit is greater than my digit, then I'm going to take my digit, my goodness, plus 10, and we'll say borrowed is true. We'll go borrow from the neighbor. Okay? And then I can add that result. So then I can take the result, digits, and I can insert, add at index 0, my digit minus the other digit. Right? So if it's bigger than me, I need to go borrow. So we'll add 10. We'll mark it as borrowed for the next time around. We'll go add that digit. And then we'll take my index, minus minus, and the other index, minus minus. That should go all the way through. Right? We'll get mine. We'll see if it was borrowed. We'll subtract it by 1. Okay? Then get the others. If it's bigger, we need to borrow again. Go add it in. So it should keep on cascading that borrow if needed all the way down. Okay. Then when we get to the end, right, I don't know. Now the other should not have any digits left, but it's possible my has left because I know the other's smaller. Right? I'll kind of save some of this little easiness here. So we don't have to repeat as much. I feel a little bad having this repeat code here, but oh, this is not, that needs to be a while. Shoot. All right, yeah, this while my index and while the other index, because I didn't know which one was bigger. I guess we could have checked which one was bigger first, but that's okay. Not too big of a deal. I can always clean it up later. All right, so once this while loop is done, I know my index might have more, but theirs must be done. I'm going to say while my index is greater than or equal to 0, let's keep on going. Now the only thing I have here, I don't have the other digits because there's nothing to subtract. Right, so I can check one time this if borrowed thing, subtract it, and then we can add the digit in. there's no subtraction here. It's just taking the digit. Okay, so if there was a borrow, great, keep on cascading that borrow on down. If not, we're done. We just take our digits and throw them in at the front. And then we're done. We're going to return the result. Now again, we're not checking for positive or negative here. We're just saying, hey, I'm assuming I'm going to do the smaller from the bigger. You can figure that out after. Okay, so we test some additions. So here's adding two positives, adding a positive and a negative. Let's do a similar thing here. Just copy these in. So if I do negative 123, okay, and I add them together, my result there then should be them subtracted. So I should get, is that 111? Right? First, add the second. I should have a positive 111. Let's give that a shot. Hey, that one passed. All right, that's kind of exciting. I wasn't sure that was going to work right away. Okay, and then for fun, let's flip it around. Positive, negative again. I don't know. Let's do second, add the first, just to make sure either direction works. So this is a positive plus a negative rather than a negative plus a positive. Okay, that one works. And for fun, let's do with a negative result. Negative again, negative result. So if it's negative 234 plus 123, I should get a negative 111, right? Negative 111. With negative result, right? Negative results. Let's try those. And let's run them all. Can we run all the tests? Yeah, look at that. They're working. That's pretty exciting. Okay, so addition seems to be going. Let's see, we did two positive. Let's try and add two negatives, right? Because we know we also had that case. Let's add two negatives. So if they're both negative, right, the whole thing should be a negative 357. Look at that, seems to go. All right, so now we just need to tackle subtraction. Okay. Oh. So, with subtraction, now, oh yeah, now I'm feeling bad because this is subtract smaller. This add one here, bummer. Because if we are negative and we're subtracting a negative, that one's subtract. So what can we get that actually is addition? If we're subtracting a negative. So if we're positive and we subtract a negative, that's really addition. If we are positive, we subtract a positive, that's subtraction. Great. If we are negative and we subtract a negative, it means we're going more positive, that's subtraction. Because this subtract smaller from bigger should work if we're positive and they're positive. So if we're both positive, right, we'll subtract the bigger from the smaller and see what we get. If we're both negative, I'm negative, we're subtracting a negative, well, that's regular subtraction, right, because we're actually going more positive. We're not adding them together. If I'm negative and I'm subtracting a positive number, that's like addition. Or if I'm, oh man, there's so many cases here. I'm hurting my head here. Okay, so let's look at the first one. So if we are positive and other is positive, that's a subtraction. Okay, easy. Okay, what is the other case? So if we are negative and they are negative, or we're subtracting a negative, right? Okay, so this or not positive and other dot positive, not positive. Okay, so positive minus a positive, we need to subtract the bigger from the smaller. A negative minus a negative, and we're going to subtract the bigger from the smaller. Okay, let's try that. Let's see. So we should be able to go then. We can say if is bigger than the other. Oh, look at that. I have some right over here. We'll move our note. So if we are the bigger one, then we're going to say subtract smaller from the bigger, given the other. Then the sign. So if we are positive and they were positive and we were bigger, we're going to be positive. If we were negative and they were negative and we were bigger, we're still going to be negative. So our sign then, we're going to have a BigInt result equals this. BigInt, BitInt, oh man, messing up the letters there. So my result.positive will be my positive. Okay, if we're not bigger, then we must be smaller. Let's do this the other way around. So we're going to say a BigInt result is other.subtract smaller, given this, which is us. And then if they were bigger, we're going to be their sign. Right? Because if we were both positive, no, if they were bigger and we're both positive, that's not going to work, is it? So we're going to be the opposite. So if we were negative and they were negative, we're going to be positive. And if they were positive, we're going to be negative. So we're going to be the opposite. Right? If they were bigger than us and we're subtracting, we know we're going to be negative. So that's the opposite. If they were negative and they're bigger, we're going to be positive. So we're the opposite of their sign. So the result.positive equals the opposite of their sign, because they were bigger and we're subtracting them. So if they were positive, we've gone negative. If they were negative, we've gone positive, because they were bigger. We can return result. Okay, so it's the subtraction piece here. Okay, so now if I'm negative and they're positive and I'm subtracting, I'm getting bigger. That's really like adding with a negative result. If I'm negative and they're positive, we're getting more negative. Right? And if I'm positive and they're negative, we're really adding. So I think I need a way to add. So I'm going to try and move some of this add logic out. Let's do that there. Let's take all of this. Take all this out. And we're going to do a little helper method here. We're going to have a private BigInt, there we go, add smaller to bigger. Ignore sign. Given a BigInt other. Okay. So, and if I'm, didn't I say add? Oh, I just copied it. Okay, so we're going to add smaller to bigger here. That's right, I just copy pasted it. So if I know that we're always bigger, then I don't have to deal with any of this other index stuff, which is nice. I think we should be able to get rid of some of that then. We just need to deal with the results here. So if we're positive and positive, we're going to check to see which one's bigger. If is bigger than the other, is the add smaller to bigger, and then positive. Otherwise, it's the other is bigger, and we're going to add ourselves to them. And it should be if the other was positive or not. We'll keep their sign. Okay, I think that'll work. So, is that too many curly braces now? Oh, no, that was right. That was the if there. Okay, give that a format. We're just trying to move that add logic here. Let's make sure our tests didn't pass. This is the great thing about tests. As we're changing that up, if our test failed all of a sudden, we knew we probably messed something up with that change. But now we're going to add smaller to bigger, ignore the sign. So we can go back to our negative here, then our subtraction here. So this is the other case then. We want to do that addition that actually happens behind the scenes. So we're going to see who's bigger. So we're going to check if is bigger than the other. Then we're going to add them together because either I'm negative or they're negative. So if we're bigger, right, and we're doing the subtraction, if we're subtracting a positive from us being negative, we're getting bigger. Right? If we're negative and we're subtracting a positive, we're getting more negative. So let's figure it. So if we are bigger, then let's see. So does this end up both being negative? So either we're positive and they're negative, we're getting bigger. We could be positive, or if we're negative and they're positive, we're getting more negative. Okay, so the result then is going to be either positive or negative. We'll have to figure it out based on us. So if we are bigger, then we're going to take a BigInt result is add smaller to bigger, adding them to us. And then our sign is going to be, so if we were positive and they were negative, we've gotten bigger. If we were negative and they were positive, we've gotten bigger. So the result positive should be our positive. Then we can return the result because we're really like adding here. Okay, if we're not bigger, if they're the bigger number, right? That's the, now I guess really an else, but not even an else at that point. I guess we used else's before, so it's probably fine. Yeah, that's fine. We'll just use an else. Say else. They must be bigger, so my BigInt result is going to be other.add smaller to bigger, given this, which is us. Okay, so if we were positive and we were subtracting a negative and they were bigger, that's fine. We're still going to be positive. If we were negative and we're subtracting a positive, we're still, so I think we keep our same result here. Let's try that. I think we keep our same sign because either we have added more to our negative or we've added more to our positive. We should stay the same. We'll see. We'll see if that works for us. Let's try some subtraction tests. Do we have any? Yep, subtract. Difference of, oh, that's add ints of different size. Oh, there we go. Okay, I didn't finish that test out. There we go. Int of different sizes. So if we have 1, 2, 3, 4, 5, 6, and we add a 2, 3, 4, right, we should get, oh, let's throw a carry in here somewhere, right? So let's do, how about that? We'll do 99999, 6 nines, and we'll add 1. We should end up with 1 million, right? Let's try that. I'm curious. Uh-oh. Expected 1 million. We didn't get our last carry. All right, we found a bug in add. This is good. This is good. So our bug in add then, where's our add? So if there was a carry, right, we need to add one last one because there might have been a carry here where we added the 0. So one last check. So if carry, after we're all done, we'll add a 1. That ought to pass that test, right? Because we were missing the leading 1. So let's run that one again. All right, okay, that one passed. Good, 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 good. So we're able to carry with different sizes. Feel better now. Okay, now let's check some negatives. Let's do some negative tests, some subtraction tests. So add test, public void, test subtraction. And we have a couple cases here, right? That we were dealing with. So where's our subtraction? Let's see, here's subtract. Okay, either we're both positive or we're both negative. Okay, or we're one or the other. So let's try a couple. This is both positive. We'll do one that's, let me just grab a couple here. Okay, so we're both positive and we're subtracting. So let's do first, subtract the second. Come on. Just find the word second there. Come on, NetBeans. Second. All right, so then our result then would be 999,998. If we did that one right. Oh. 999. Oh, we had another leading comma again. Oh, okay, so our comma check is bad for us, because we're putting a leading comma in there. Let's see, that's our toString. So I think actually we want, instead of being size greater than 3, we want index is not 0. We never want a comma before index 0. So if index does not equal 0, I think that's going to work better. Let's run our tests. Okay, there we go. So now we don't have to deal with that leading digit there. Okay, so the first subtraction worked. How we subtract both negative. So we're negative minus a negative. Oh goodness, is that right? So subtraction, if we're both negative, and we're subtracting a negative, it's like adding. Oh yeah, okay. Yep. Subtracting a negative is like adding, okay. So that ought to work. Let's try that one. Cool. So now we need to do one of each, right? So negative minus a positive should put us at negative 1,000,000, right? Okay, good. And then how about a positive minus a negative? Positive minus negative here. So we take the first, subtracted the second. We should end up at positive 1,000,000. Okay, that's looking good so far. I think our different cases feel pretty good. How do you folks feel? We got toString, we've got positive, we got negative. Let's take a look. We do have everything. All right, let's see. So we have an array list to store the digits, a constructor, a Boolean to indicate positive or negative. Our methods create new results. There, we subtract makes a new result. toString prints it out, and unit test coverage. Okay, I think we're feeling pretty good about these here. What we didn't actually check, though, is that we didn't change the originals. Right? So we could add another assert here with some of these to make sure we didn't change any of the originals. I'm not going to do it on all of them, and I probably didn't expect this from any of you folks, but that's okay. So we would say, hey, we'd have negative 999, and my first toString. Right, and then we'd assert equals a 1 and the second toString, right, just to make sure they didn't change. toString. Right, let's give that a run. Okay, so that looked good in the subtraction. We'll add a couple here and some addition somewhere. Sure, let's try that here. So first should be positive, second should be positive. Right, and none of them should change. Right, this is just one check to make sure, hey, once I create it, that didn't actually change on me. So it's good to check there. Okay, how's that feeling, folks? It's a recording. You're not live. Habits are hard. Habits are hard. All right, well, thanks. If you have any questions, thoughts, concerns, let me know, and we'll go from there.